Hello, am I audible?
Should we start now?
Yes, ma'am, sure.
Hello, am I audible?
Should we start now?
Yes, ma'am, sure. Thank you, ma'am.
Thank you, ma'am.
You can please start.
Good afternoon to all. Actually, in this program, am I audible?
Yes, ma'am, you are audible and visible too.
Lovely. We are on the second day today of the 5-day faculty development program on the effect of generative AI in modern research and industry. It's excellent on this sunny, hot summer afternoon. Nice to be cool, listening to one another. Generative AI is having a profound impact on modern research and industry, revolutionizing various aspects of these domains. The objective of this program is to provide educators, academicians, researchers, and industry people with a comprehensive understanding of generative AI and its applications. I'm happy to share that we have over 2,500 participants from all across the globe today here. Thanks to the virtual platform that we are using, and thanks to all our esteemed faculty members, researchers, academics, missions from Sister Nivedita University. I wish you all a very knowledge-gaining session. Thank you, dear all.
Thank you, madam, for your valuable words.
Dr. Shubhi?
Always it is very motivating for us. Always you inspired us in this way for each and every event. Thank you, ma'am. So today I just want to welcome
dear.
Thank you. So today I just want to welcome our esteemed speaker, Dr. Saptarshi Ghosh. I think our speaker has joined. And along with this, he is also accompanied by his research scholar, Aniket Deroy. Dr. Ghosh is an associate professor at the Department of Computer Science and Engineering at IIT Kharagpur. His primary research interests are in legal data analytics, social network analytics, and algorithmic bias and fairness. His research is interdisciplinary and he uses techniques from machine learning, natural language processing, information retrieval, computational science, social science, and complex neural network. Information retrieval, Max Planck Partner Group at IIT Kharagpur, and focuses on algorithmic bias and fairness. He received his PhD on computer science from IIT Kharagpur in 2013. He was a humble postdoc research fellow at Max Planck University for Software System, that is MPI SWS, Germany. His current scholars and Google Scholar citation is 5,134 and H index is 38. So he is also accompanied by, he's one of the research scholar. He is Aniket Devroy. Aniket Devroy is currently PhD student at Department of Computer Science and Engineering at Kharagpur. He is supervised by Dr. Saptarshi Ghosh and Dr. Ghosh at IIT Research Group at IIT Kharagpur. So he's Shipur and he completed his MTech from IIT Kharagpur. So without wasting any time, I will directly request our speakers to hand over the session to you for the next few minutes. Thank you.
Okay, thanks, Shomi. Am I audible?
Yes, yes, sir, you are audible.
Okay. So, okay, I am momentarily opening my video. Hello all, and thanks. I thank the organizers for organizing this event and inviting me. But I understand that the network connection is a bit weak, so it's better that I switch off my video and present the screen. Otherwise, the voice is getting a bit disturbed.
Yes, sir.
Yeah, okay. So let me share my screen. Is this visible?
Yes, sir, your screen is visible.
Okay, thanks. Okay, so hello everyone. Yeah, I would start by thanking the organizers for organizing this event. And so we are today going to talk about generative AI in two domains, education and legal domain. So the plan is like this. So I'll start and then a part of it will be presented by senior PhD student, Aniket Deroy. And then I'll take over the next part of the talk. So we all know that generative AI models have become both huge and they have become hugely popular. So when we say that generative models have become huge, this is usually measured in terms of the number of parameters they have. So at one point of time, we used to have models with thousands of parameters, learnable parameters. Then came the era of millions of parameters. Like you have BERT and other models which have several millions of parameters. And now the sizes have increased to billions of parameters, and no one really knows where things will stop. So almost every month we are having a new generative AI model or a large language model being unveiled. Now, of course, the reason for this is that these models are actually very good in very different tasks, and they have become very popular in different domains. So for example, this is just a small list. They are today being used in education, healthcare, law, sustainability, including agriculture, urban planning, and many more. Also, like in this talk, we will focus mainly on text-based models, like large language models. But also nowadays, there are vision language models, which can take images or even videos and then do different types of analysis on them. And also, so these models, they have many uses, but also there are lots of dangers or concerns associated with them. For example, these models can read text. And imaginary text can have very bad properties. For example, fake news or what we call hallucination, like things which are not there, actually, these models can generate even those kind of text. So we will see some of the examples in this talk. Now, out of all these domains, this talk will focus on two domains. One is the education domain, which I think would be especially of interest to you all, because I understand most of the participants here are faculty members at different institutes. So specifically, Aniket, my PhD scholar, will talk about using large language models or generative AI models in the education domain, especially for generating questions. So I think we all know that we all faculty members have to generate questions or have to prepare questions for different exams. So large language models can actually do that job very well. They can generate different types of questions, which Aniket will show you, like multiple choice questions or short answer type questions and so on. Next, in the next part, I'll again take over and then I'll talk about use of generative AI models in the legal domain, especially for summarization of legal case judgments. So with that, I hand over the stage to Aniket. So let me stop sharing the screen. Aniket, please share and go on. Okay, so Aniket, you are here, right? Aniket, are you here? Okay, Aniket told me he has joined. Aniket, are you here? Give me a minute, sorry. So show me, it seems Aniket cannot. Can you make Aniket a presenter? Like it seems he cannot unmute or he's not allowed to unmute. Hello, show me, am I audible? Hello? 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 तुम्ही मीटिंग Hello, organizers, can you hear me? Organizers, Aniket needs to be made a speaker or I have informed the organizers that they are making Aniket a speaker.
Aniket, you can unmute yourself.
Yes. Am I audible now?
Yes, yes.
Okay.
Yes, Aniket, please share your screen. Yes, we can see your screen. Yes. So I think you can start.
Yeah. So thank you for giving me the opportunity to talk here. So I'll be discussing the use of LLMs for educational question generation. So the first, we are going to discuss two papers. One is on subjective question generation. The paper title is Harnessing the Power of Prompt-Based Techniques for Generating School-Level Questions Using Large Language Models, where we are going to show how by using large language models, we are able to generate school-level questions, basically subjective questions. So first, for generating the questions, we have built a data set. So the data set consists of 4 parts: context, long prompt, short prompt, and question. So the context is basically the segment from the textbook which is taken upon which the question needs to be formed. So we have taken textbooks from 6th standard to 12th standard NCERT textbooks, and from that we have taken passages of average length 70 words, and after taking those passages, we are considering them as segments upon which the questions needs to be formed. Then we have taken long prompt. So the definition of a long prompt is a long textual cue for the question. Basically, it gives an indication to the type of question that needs to be formed from the particular context. So the long prompt and the short prompt both act as indicators for the type of question that needs to be generated from the context. And the short prompt is a short textual cue for the question, basically a condensed representation of the key information or focus of the context. Primarily, we select a noun phrase from the beginning portion of the context to serve as a short prompt. Then we have the question or the gold standard question, a question that aligns with the context and is coherent with the prompt. So one example is given below. The purchasing power parity PPP is an economic indicator that signifies the purchasing power of the currencies of various nations of the world against each other. It helps in comparing living standards between different countries and estimating economic productivity. So this is the example of a context. Now the annotators have marked two prompts. One is the long prompt, which says purchasing power parity helps, and then there is short prompt, which says purchasing power. Now the gold standard question, which is being formed from this context, is what does purchasing power parity do? Now this is one sample from our data set. Now we'll talk about the probabilistic model and how we have used the probabilistic models in the form of large language models to generate questions. So a probabilistic model is basically a mathematical framework used to represent uncertainty or randomness in a system. It's a way of describing the likelihood of different outcomes occurring. In such models, various factors are described using probability distributions which assign probabilities to different events or states of the system. These models are used extensively in statistics, machine learning, and AI to make predictions, analyze data, and make decisions under uncertainty. Now, we have used these probabilistic models in 3 different scenarios: with long prompt, with short prompt, and without prompt. So in long prompt setting, we have tried to predict the probability of the question given the context and the long prompt. So the context, long prompt, and the forms a part of the data set. And now by using this large language model, we encode the context and the long prompt into the large language model to check what is the question that is being generated, and then finally we will compare the generated question with the gold standard question. Similarly, with short prompt setting, we do the same. Just the difference is here we use a shorter version of the prompt. And we also try the same without a prompt, where we only put the context into the LLM and ask it to generate a question, and then compare it with the gold standard question that is present in our data set. Now, this is the approach that we have followed. So on the left hand side, there is a square shown in red, which gives the context. Now, from this context, we have created the gold standard question, long prompt, and short prompt, and we have passed them through the QG models. The QG models are basically the large language models which are trained for generating questions. So based on after training the models on the task of question generation, we have given examples of the type of questions being generated. So for using the long prompt setting, the question that is generated by a large language model, in this case, it is T5. So T5 is a large language model. So the question generated in the long form setting is, what is the importance of purchasing power parity and how does it help us understand the situation of the world economy? Now, under the short form setting, the same question becomes, why is it important to have a good knowledge of the purchasing power in order to make informed decisions? And without using any prompt, what is the relation between living standards and economic productivity? So we can see that by using different prompt settings and also without any prompt, from the same context, multiple questions can be generated. So by using different types of prompts or without using any prompt, you can generate different types of questions from the same context. So that is what we wanted to show in this work. So the educators have the advantage that if they feed a context and a prompt into a large language model, then they can get different varieties of questions. So let's discuss briefly about our dataset that we created. So our dataset mainly consisted of 4 types of questions. First one is the procedural questions. So these are about the procedures or methods used to accomplish specific outcome. Majority of these questions are initiated with how and are followed by a modal verb or auxiliary verb. So 2 examples have been given. How did Pandita Ramabai break stereotypes and how did Brahmo Samaj reform Indian society? Next is the cause questions. So these are focused on the reason or cause behind a concept or event. The majority of these questions commenced with the word why, which was followed by a modal verb, auxiliary verb, or their negative counterparts. So again, 2 more examples given. Why is the Ganges River dolphin blind? And why is urban waste disposal a serious problem in India? Next is the verification type question, where we are trying to verify the trustworthiness of a concept or event. The majority of these questions are formulated as general questions, initiating with verbs, modal verbs, or auxiliary. Does universal basic income or UBI reduce poverty? And the second question is, are Vedas older than Puranas? Next type of question is the consequence question. These questions focused on the consequences or outcomes resulting from a particular event. The majority of these questions employed phrases like what happens, how does it affect, and so on. So two more examples of the consequence type of questions. What happens if oceans acidify, and how does the government deficit affect the economy? So these are the different types of questions that are part of our data set. Now, going into some of the prompting methods that we used, prompting methods for generating questions from the LLMs. Now, with the long prompt setting, the prompt that we used is, given the context and the long prompt, generate a question. Now, for the short prompt setting, the prompt is similar, given the context and the short prompt, generate a question. And for without prompt setting, given the context, generate a question. Now, let me show some examples of the questions generated from the context. So again, you are seeing the same context, long form, short form, and gold standard question, which I showed earlier. And the examples of the different types of questions being generated are also shown. So Da Vinci with the long form. So Da Vinci is a large language model, which is developed by OpenAI. So Da Vinci with the long form setting gives the question, you can see it. How can the concept of purchasing power parity be leveraged to not only compare living standards and estimate economic productivity between different countries, but also address global income inequality and promote equitable economic development on a global scale? Now, Da Vinci with a short form setting gives the question, how can the concept of purchasing power be harnessed to foster international collaboration and create a more equitable global economic system that promotes shared prosperity and uplifts disadvantaged nations? Now, without prompt, in the same scenario, the question becomes, in what ways can the utilization of purchasing power parity act as an economic indicator, be expanded beyond its traditional applications to promote sustainable development, address socio-economic disparities, and foster international cooperation for the betterment of global economic systems? Now, under ChatGPT, which is very popular these days, so we also use ChatGPT to prompt using the context, long prompt, short prompt, and without prompt setting. And we receive the same question, we receive different questions from the same context. So let me read out the questions. What does purchasing power parity indicate and how does it assist in comparing living standards and estimating economic productivity among different nations? Now, with short form setting, the question becomes what does purchasing power parity represent and how does it facilitate the comparison of living standards and estimation of economic productivity across different nations? And without form setting, the question becomes how does purchasing power parity serve as an economic indicator to measure the purchasing power of currencies across different nations and what are its implications for comparing living standards and estimating economic productivity. Now, for fine tuning, so there are some models which we directly used through prompting, whose examples we just showed in the earlier slide. Now, next, here we used fine tuning. That is, we trained the models on the question and context pairs along with the questions and then ask the models to generate the question based on the prompt and the context. So with long prompt, during fine tuning, we pass the input sequence as context, long prompt, and gold standard question. And during testing, we format the input sequence as context and long prompt. And we ask the model to generate a question. And then finally comparing the generated question with the gold standard question present in our dataset. Similarly, with short form setting, we fine tune, we format the input sequence as context, short prompt, and gold standard question. During testing, we format the input sequence as context and short prompt to generate the question. And without prompt setting, we do not use a prompt. We just put the context and the gold standard question during training, and during testing, we only pass the context to generate the question and compare the generated question with the gold standard question. Now, these are some examples which are generated by fine-tuning the LLM. So, we used 4 different models. One is Pegasus, another T5, another MBART, and then BART. So, let me read out the questions that are generated by Pegasus. What is the importance of purchasing power parity? How does it help us understand the situation of the world economy? So here you will see with the Pegasus model, the questions, there are 2 parts of the question. So earlier, the questions were, if you have to answer the questions, you need to understand them more. And now here the questions are more direct, but there are sometimes there are multiple parts of the questions. Then with the short form setting, why is it important to have a good knowledge of purchasing power in order to make informed decisions? And then without form setting, what is the relation between living standards and economic productivity? Next, with T5, with the same long form setting, how does purchasing power parity help in economics? Read more about how does purchasing power parity help in economics. So this is some of the problems that there is in the question generation process. So we showed this example. Read more about how does purchasing power parity help in economics. So these are some of these things which need to be verified by human experts before you generate a question from a LLM and give to the students. So if you are using LLMs for generating questions and directly putting them in the question paper, that would be more challenging because there may be mistakes generated for the questions generated by the LLM. So you need, after generating the questions, you need to verify once. So that was one of the examples. Then with T5 with short form setting, what is the purpose of purchasing power? Then T5 without form setting, what is the importance of a country's development index? How does it help the poor? Next with MBART with long form setting, what does rupee purchasing power parity do for people living in economics? And then MBART with short form setting, what is the importance of purchasing power in daily living standards between 2 countries? And MBART without form setting, why is it important to read a country-based economic pattern? Give example of poverty. So again, similarly with BART, long form, short form, and without form setting, we get 3 different questions. So what I wanted to show here is that with the same long prompt and same context, for different models, you get different types of questions. For example, for T5 with long prompt, you are getting the question, how does purchasing power parity help in economics? And then read more about how does purchasing power parity help in economics. But with MBART, with the long prompt setting, you are getting a slightly different question. What does rupee purchasing power parity do for people living in economics? And then again with BART, with long form setting, you are getting somewhat different question. How does purchasing power parity help improve the economic parity and why is it good? So with different large language models, with the same training data, you will also be getting different types of questions and generating variety of questions, resulting in building of a question bank. But the only thing is you cannot fully trust these LLMs, because there can be hallucinations, there can be some problems which need to be verified by human experts after generating the questions. Next, we come into the evaluation methodology that we used. We compared the questions generated by the LLMs with the gold standard questions present in our dataset in terms of Rouge to precision, Rouge to recall, Rouge to F1, Rouge L metrics, METIA, CHRF, BLOY, and BART score. And in case of human evaluation metrics, we take the questions generated by the LLMs and ask the human evaluators to rate them on a scale of 1 to 5 in terms of grammaticality, appropriateness, novelty, complexity, and relevance. Now, next we are going to show the results. So for the automated metrics, we see that for fine-tuned domain-specific LLMs, T5 performs best for long-form setting. For short-form setting, BART performs best for most of the metrics, but T5 also performs best for some metrics. And again, without from setting, T5 performs the best across most of the metrics, apart from BART, which again performs best in terms of BART score. So these are some of the results of the automated metrics. And human baseline. So we also considered human baseline, where we ask the humans to generate a set of questions based on the same data, that is the context, prompt, and prompt, and the results of human baseline is generally better than the results of the models. So the models have still not been able to reach the level of human level performance in terms of automated metrics. Next, we come to the human evaluation part, where we see that here, in case of human evaluation, DaVinci is the best performer across all the scenarios, long form, short form, and without form setting. So DaVinci here again is the OpenAI model, which we directly use through prompting, where the fine-tuned LLMs, they are used after training. And in case of these pre-trained general purpose LLMs like DaVinci, they perform well in terms of human evaluation matrices, and the results are quite close to the human baseline. And in case of novelty, the results are better than the human baseline for DaVinci. And for the fine-tuned domain-specific LLMs, the results are lower as compared to the pre-trained general-purpose LLMs for the human evaluation metrics. Next, we are so here we end the process of generating subjective questions. Now we are going to delve into generating MCQ questions. So next paper that we are going to discuss is a novel multi-stage prompt